So before we get to today, I meant to ask the other class this first, and I didn't, I waited. Any questions on the homework from the last few days, finding area or integration by area under like the shapes, finding triangles, semicircles, any of those funny things? Yep, like, because yesterday you were working on the homework, and some questions came out, but nothing new. Okay. Tonight's homework should be small. This is on the worksheet. I don't know why it's specifically typed out here, but there it is. Okay, today we're going to do some definite integrals, and that's going to launch us into the fundamental theorem of calculus, which we will start tomorrow. And you saw the email about what we're doing Monday and Tuesday next week, because a number of people aren't here. It's 2 AP problems in AP Classroom, 1 per day. Like, I do want you to, if you're here in class, I do want you to do it in class, all in one sitting, submit it all at once. If you break the internet connection, it wipes out all of your forward progress. So you need to, if you start it, finish it, because it will delete forward progress. And the last 2 that you guys did, I saw that you guys had started and that it obliterated some people's stuff, and I gave you guys credit for it. This one, I want to see all the stuff done. And if you're out of town, it's open till the day we get back from Thanksgiving break. So if you're not here next week, find time over the break to get those 2 things done. Some people are going to be off the internet, like camping. It's not what I think of when I think of Thanksgiving break, but hey.
It's more true to the tradition.
You know, cool.
Yeah.
Go sleep on cold, hard ground and hunt your own turkey. I don't know. It's going a little far for me, but so I opened it yesterday so that they could do it now before they go off grid on Friday. Go sleep on the ground. Okay, so here's some rules that we need to know for integrals. I don't know why, but I like that shape. Everyone pick a number. What does that look 13. Like? 13. Excellent. Okay, so if all of this area is 13, what if I'm now integrating, very small difference. Paolo, instead of going from A to B, I'm now going B to A. Is it still 13 or is it something different? Still 13? No? Negative 13.
What are the negatives?
Okay, so, okay. Yeah, see, so Paolo said, but under the x-axis is negative area and above the x-axis, okay. Yes, and let's look at this. The height was a positive y, dx was a positive dx, so the area is positive times positive, positive. Then I changed the bounds, and the height is still positive, but dx now is negative. So the way I explained this first period yesterday, this is your stock price. You gained in your stock price over time. If you're right here looking backwards, did your stock price lose value as you went back in time? It did, right? Like it was only worth $10 a share, and now it's $500 a share. Yeah.
Wait, so does that mean if it's below the x-axis and you're going that way, that it's positive?
Give me 2 slides.
Oh, okay.
But, so, here's the first rule that we need to know. And it's hard to see the only tiny thing. The letters change spots. This was B to A to B, and a negative. is the area under a dot?
0.
0? Because dx, did dx move? It's 0. You're standing under an umbrella and it's not open. Are you going to get wet? Integral from a spot to itself? Area under a dot, we're like, nah, negligible, 0, nothing, nada, rien. Zilch. Nah. Anyone else know? 0 or?
Null?
Null? Null is different.
It's what you listen to this though.
As the computer science person, it's different. What if I just multiply it by a constant? Do I have to do 3 times y? So it's 3 times. Do I have to like multiply it by 3 and integrate it, or can I move the 3 on the outside? It sounds like on it. And so yeah, I can move a constant in or out. If it's got variables on it, no, they're stuck. But I can move the number in or out. And first period was like, why would you ever want to move it in? If it's a negative, it might be really helpful. Okay. Wrong thing, sorry. And this one, if it's added or subtracted, you can be, all right, the area of F is this, the area of G is this, I will just add them. It only works for add and subtract, does not work for multiply or divide. Okay, Sophia, this one. What do you think? Integrating from A to B and B to C, what do you think we might be able to conclude? No? Daniel, what do you see?
A to C?
So, yeah, you can glue them all together. But I got a question. Do not guarantee the order. Does this still work? If I integrate area from A to B, Paolo, what is the area from B to C? Negative. Does it still work?
Yeah.
Yeah. So I said, add up all this stuff, back up the truck, give me just a small slice, it works. Yeah,
This only works though if f of x is the same function,
yes,
right? Because if it was like they were different functions, then it would be different. Yeah.
yes. So it is written as exactly the same function and true, needs to be the same function.
Wait, and is that the same for the floats rule also?
All the, yes, well, this one, F, I can integrate F, find its area. I can integrate some other function,
Oh,
find
yeah,
its
yeah.
area.
Okay, yeah, I get that, yeah.
Yeah? So, 2 slides. All right, so, Ben, what do you think? F of x, integrating from A to B, is it gonna be positive or negative?
Positive.
Because the height was positive, dx was positive, so positive. Francesca, integrating f of x from B to A. Because that was positive, but this was negative, so negative. All right. Alana, integrating from A to B, g of x. Negative y value, but positive dx. So this is the area under the curve, and it's below the x-axis. However, Alex, when I do this one, g of x but b to a, because that's like your stock price is still tanked. If you went back in the past, you would have lost less. Does that work, Ben? Yeah. No, not a question. So, yeah, it's area above the curve, but sometimes they make you do the moonwalking backwards. Okay. Try them all, and I will ask someone to put all of them up, and we will see if they're right.
Considering that.
Have a bribe of mesquite barbecue kettle chips for anyone who has to put all the answers on the board. Ooh, kettle chips. Constantine's trying to think how desperately hungry he may or may not be. He's like, I don't know. Mesquite barbecue chips, not my flavor. Fine. You want to do it? Okay.
you can't measure
Okay,
3
so
and 4, right?
the directions did say evaluate if
If
possible. So calculus, now they're like, solve the problem if you can. In college, they are, solve the problem, we're not sure that anybody can. Do we know what that is?
We don't know what that is, but that was as close as, so I guess that would also be a, an A. Yes.
Okay. So, this one, it's subtle. I look at these questions too quickly. And I need to slow down and be like, wait, those are upside down. Because the bounds were the opposite direction, the area is the opposite sign. This one, I see these as like a daisy chain, linking them up, -1 to 1, 1 to 4, add the numbers, 5 plus -2, 3. How come he said this one's not possible? 0 to 1 for F.
Because we have no idea what FFs are, like, anything past.
So maybe F does this, doesn't have to be uniform, I can't just cut it in half, I can't decide like, well, it's some of, like, you need to be told. What's wrong with H? Why isn't it 14?
Because it only works, it's a coefficient outside of h of x, not the bounds.
Okay, because what if it was just a semicircle and it's not actually defined outside of -1 to 1? So it might have a value, but not from the information I told you. This one, 2 times that, and 3 times this, 31. This one, Andy's like, well, that guy was
3.
3. I don't understand why it's a 10 here then. But
Well, I was just getting as far as I could.
Okay,
It
so-
was this, because I knew from -1 to 1, h of x was gonna be some.
Okay, that's what I needed, thank you. And then he's like, plus whatever that is. But I didn't tell you what that is. Okay, fine, so it's not known. Correct. Good? Okay. So mean value theorem, can anyone tell me what mean value theorem was back in the day? Ben?
Like, you have like a derivative, and like the average rate of change is just one point between point A and B, where the average rate of change equals the instantaneous rate of change.
Okay, so if I have a function that's continuous over the closed interval and differentiable over the open interval, there has to be a place that the average equals the instant. This was us putting Katie Harvey in jail. It's my favorite day. If you are doing 20 miles an hour, but you were averaging 40, sorry, officer, I'm doing 20. No, you were averaging 40. Somewhere in there, you you had to have been doing 40 and probably faster. Okay, so mean value for definite integrals, it's to find what is that average value. And I see this as, if this was an ice block and it melted, and it's in a little container with steep sides, when it melts and fills in all this space, it's the height of where that water will be. Okay. So there's 2 things that we're gonna do. Can you guys see this at all? That's an A to a B. So the average value of a function over A to B, find, like, this is like the temperature that we did. We added up all the temperatures for the day, and then we divided by the number of hours in the day that we took our data. We got the average temperature was 65 degrees. Yeah? Okay, so those of you who know how to integrate already, cool, go for it. Those of you who don't, get out a calculator or Desmos. So there's two questions. One is find the average value, and then at what value, like where is the x value where the function hits that average? What is the average value? 1, 1.5? Different answers. Who corroborates 1 or 1.5 or something else? Did anyone get the other answer?
Is there another answer? Is it 1.7?
Okay. Well, okay. First question, where does the average equal the instant? So, or sorry. 1 over 3 minus 0, the integral from 0 to 3.
Oh, yeah, that's
That came out to 1. That was the first question. So, graphically looking at it, the way I think of it is, oh, come on. If that was ice and it melted, this stuff filled in that gap and the height of the water was 1 foot high. Okay? So that is the average value. This second question is saying, what x values does it hit that average?
X equals 1. No?
Well, where does the function equal that average? Plus or minus root 3, both answers work. No, Paolo, which one works? Positive root 3. So AP is irritating and inconsistent with this. Sometimes they're like, oh, no credit because they didn't restrict to the domain we asked about. And sometimes they're like, oh, it's okay, they gave us both answers, it's all right. I don't know when they decide to be picky and when they don't. So just giving a heads up, be cautious. Try to be more careful and read where they're looking for. Do any of you actually know how to integrate yet? I mean, some of you
Sort of.
sort of, because you were taught that in a day in physics?
Yeah.
Yeah?
Can you
Well, not really. It's
do power rule backwards?
Yes, actually.
Okay, that,
Well, like, so when you get to like 4x minus x cubed over 3, but then, okay, so I was gonna ask about like, where do you plug it? Okay, so you did the top minus bottom first.
Mhm.
That's what I thought.
So, those of you who have no idea what we're talking about, Daniel said, so is it reverse power rule? So power rule was multiplied by the power, lower the power. Reverse power rule, raise the power, divide by the new power. And then fundamental theorem of calculus, how do we evaluate it? Okay, once we've integrated, the squiggle on the left becomes a straight bar on the right. Plug in this guy, minus plug in that guy. We will do it tomorrow, but some of you knew today. All right, just checking. Can you do this one? Find the average and where in the function, so it's 2 parts. What is the average? And find the x value where the function hits that average. What'd you guys get? The average is 0, so what is the value?
1. Actually, at 1.
Squared. And then, so at 1? Yeah, okay. Questions? Andy, are you allergic to them?
Mayhaps.
What, mayhaps?
Yeah.
Okay. See if I can find a different thing.
No, it's fine.
Okay. So I want to show you guys free response questions. This, gosh, it's from the last 5 or so years. questions 1 and 2, always with calculator. Since 2008, questions 3 on or without. So this is a without a calculator. And reading the question, the twice differentiable function, whether they want it or not, I'm going to say, because it's twice differentiable, it is continuous. Just because that's a zinger on every exam. This W, not the data here, but W, not W prime, models the volume of water in a reservoir in gigaliters, where T is measured in days. This table gives sample times in the interval 0 to 30 days. At time 30, the reservoir has 125 gigaliters of water. Okay, given that information, can you guys use the tangent line to approximate, tangent line at 30, what is the volume of water at day 32?
Because the slope at 30 is, oh, I see, and then we give us 25 the water. Yeah, I suppose.
We chop it, not that I have for his marketing, I just why, so it's probably mine.
It's plus, yeah, it's plus, yeah.
Just for, future drawings, and we sure that
Take the integral of that to find the volume. Wait, no, because this is the tangent line, which is the derivative, so like in order to get the volume, you have to integrate it. Yeah. So it'd be
A W of 36 was 125, and you're adding 0.5.
I could just say y equals.
Or gigaliters. So it's 126 gigaliters.
I was trying to do it.
Okay, so the tangent line, you needed to read the stem of the question again. The very last line in there was like, oh, by the way, time 30, the y value is 125. So y minus the y value equals, oh, where's the slope? Gotta look in the table. Where at w prime of 30? And then use that tangent line. When they're asking you to use the tangent lines, don't do the distribute. Like, leave this on the outside because they're going to pick something nice in there, especially if they give you, oh, at 0.7. Make 0.77 over 10. Make it a fraction that you like. So in the grading rubric, it is 1 point for the answer of 126. You don't get partial credit for finding the tangent line. You had to get the whole thing. Okay, the second question. LRAM, 3 subintervals. Notice they didn't say equal. Look at the dx. Not the same. So you got to find the area of rectangles all on your own without a calculator. Okay, sorry, but I mean, come on. The first one is times 10. Jeez. The other one is times 1. Okay, so there's one calculation you, come on. First period was really pissy. I'm like, people, come on.
It's because they're grumpy in the morning.
Me too. So, bring it on. Yeah.
How do you show the work?
Okay.
You want to write it down on paper.
Thank you, Captain Obvious. Okay, but all right, valid question. How do you show, because, calculus, you guys are pretty smart, and as I just said, it is just stupid arithmetic, right? Well, this is equal to LRAM. The left times dx plus the left times dx plus the left times dx. That's the word. Yep.
Wait, if we want to make it easier for ourselves, can we like if we're showing multiple steps, can we like say that the integral equals like a variable and then like say the variable?
Why does that help?
Because
To
then
me,
you only need to write out the integral like if you have multiple lines.
you're not gonna have multiple lines. That's it.
But that's all you have to show.
Yeah,
And then you can just say the answer.
yeah. And actually, okay,
Alright.
for my class, go through and find a number for me, damn it. But in May, when you take the exam, you can stop there. If it is something that clearly all you had to do is punch in on a calculator, on the AP exam, as the AP grader, I curse you all, but you can just circle that and be like, done.
Oh really? That's all you have
Yes.
to do.
Andy,
Oh, wait, never mind, I read the question wrong.
good talk. So here is their grading rubric for that one.
Wait, also this was got is it y prime t dt or is you just write d for a reason?
No, it's the,
It's dt.
it didn't, my finger didn't.
No, I just want to make sure that you write
It
that
is
for, like, a
dt.
reason. Okay.
And right now,
Okay.
it's there. Sorry. So, the grading rubric says, left Riemann sum. That's saying that you wrote out these, I did this times this, this times this, this times this. And this is an old one. New ones will now say, if they wrote 5 of the 6 numbers correctly, they will get that first point. If you wrote 4 of the numbers, right, and got 2 of them, like, if you said, oh, well, the dx is 10 for each of them, no, no love. If you just did this, Ben, and circled it, you get point 1 and 2. If you did the stuff in pink and then did the algebra, the arithmetic wrong, you get point 1, not point 2. And then whatever you got for your answer, if you use it correctly in number 3, you get the third question. But why are we not done? Well, this said, use your approximation to find out how much water was in the tank to start with. Okay, now we need to understand what integration is. So that integral is how much volume changed in the tank from time 0 to time 30. So if I want to go backwards to 30, I needed to say, well, I have this much in there now. Subtract the accumulation from 0 to 30, and I get what I started with. And this is tricky because it's not necessarily always adding. Maybe there was a leak at some point in time, and so it's not being obvious, do you add or subtract? Issues, questions? Yeah.
We have to show units though, right?
It does not say here, so nope.
Oh. Okay.
This, but then, yeah, they are fickle with that as well. If they say include units in your answer, oh yeah.
But if they don't say and you include it, you won't get penalized for that, right?
You won't get it wrong, but you better make it correct.
If you
Oh,
put
right.
put in the wrong units, do you get the point off?
Occasionally.
No.
Again, it used to be absolutely always if you put the wrong stuff, you got it wrong. They changed all the grading last year. It used to be, you got a 7 out of 9, you got a 4 out of 9, you got a 3 out of 9. Now there are these 9 points that you need to earn. Okay, so this guy right here, if you wrote that, you get the point. If you wrote one of the numbers wrong, you still get the point because they understand you know how to do left Riemann sum, you just read something from the table incorrectly. And if you read the thing from the table incorrectly, you don't get the second point. They do want the answer at some point. But if you use your wrong answer correctly for step 3, you will get the point. And if you added incorrect units on this one, I believe they would be like, just let that slide. Because they are wanting to test that you've got that crux of the calculus concept. They're being less nitpicky on other things and worse for, anyway. Okay, sorry. They surprise me every year. Huh. Ooh. Explain why there must be at least one time t other than t equals 10, such that w prime is 0.7. Anyone got a reason?
Because it goes from 1 to 0.5, and how this question is set up, it cannot instantly change. It has to be continuous. The WT has to be continuous.
Okay, Constantine?
Could you use like intermediate value theorem?
Kind of. To use a theorem, you need to say that the conditions.
It's continuous because it's differentiable.
Okay. Because it's differentiable, it's continuous, and by intermediate value theorem, okay, there's more to it, but
I
yeah.
was gonna say mean value theorem because between 22 and 30, the W prime of t goes from 1 to 5, but 1.0 to 0.5, and you know it's continuous because it's twice differentiable. So the mean value theorem applies in that interval.
Oops. Okay, so because W prime is differentiable, W prime is continuous. And yes, by intermediate value theorem, W prime, so Ben, you didn't need to do mean value theorem. They're asking about W prime itself.
Oh, they were just asking about it, okay.
So, but here's the thing that I didn't know till last year. Students needed to say, well, these values, these specific values on the function are here to here. 0.7 had to fit in between them. Like, really? They said, yeah. Like, I would have lost the point last year. I said a lot of things in my answer key, but I did not say the things they wanted. Yep.
So we have to say W prime.
Well,
Or can you just say
you-
between 0.5 and 1?
Yeah, okay, yeah. You could say, like, somehow either 0.7 had to be between those two, or this is probably better, these empirical numbers between 0.5 and 1.0, the function had to have hit that in this time frame.